Hello student, I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I was discussing numericals based on electrochemistry. Many numericals I have finished. That was somewhat medium. But now I am going to discuss numericals which is somewhat difficult and are different types. Now first question I will discuss you. Question I am reading, just listen carefully, then it will be easy to understand. Standard question 1, standard electrode potential. Standard electrode potential for OCl, Cl, this is electrode, and other electrode is Cl minus Cl oblique half Cl2, respectively are 0.94 volt and 1.36 volt. The standard electrode potential for OCl minus oblique half Cl2 will be, first option is given 0.42 volt, second option is minus 2.20 volt, third option is 0.52 volt, fourth option is 1.0 volt. Again I am reading the question. Standard electrode potential for OCl, Cl, OCl minus oblique Cl minus and Cl minus oblique half Cl2 respectively are 0.94 volt and 1.36 volt. The standard electrode potential for OCl minus oblique half Cl2 will be, first option is minus 0.42, second option minus 2.20 volt, third option 0.52 volt, fourth option 1.04 volt. How will you solve? Just to now I am explaining you. Here you can see two electrodes are there. First electrode is this oxychloride electrode. Second is this Cl chloride ion is converting to chlorine gas. This is the second electrode. Correct? Electrodes are not common, uncommon, and their these things electrode potentials are given. For first electrode, its potential is 0.94 volt, and for the second electrode, its electrode potential is given minus 1.36 volt, and you have to calculate a standard electrode potential for OCl minus oblique half Cl2. This is I can say different type of numericals. Here you have to calculate electrode potential, but not for cell. This is a little different. You have to calculate electrode potential, but not for cell. This is for another electrode OCl minus oblique half Cl2, means oxychloride is converting to chlorine gas. This is the electrode. For this electrode, you have to calculate a standard electrode potential. How will you calculate? Now I am telling you. Listen carefully. Here you can say first reaction OCl is converted to chloride ion. This you consider. OCl minus oxychloride is converted to chloride ion, and its potential is given 0.094. And for other electrode, reaction is like this. Chloride ion is converting to half Cl2 and its electrode potential is minus 1.36 volt. Then you want to calculate for this OCl oblique half Cl2. Then this first reaction you consider as one, you can say one equation. Second, you consider as a second equation. Now, just you add both equation, both reaction you add, both half cell, just you add. Then what you will get? Means this and this and this, two reactions are there, half, just you add. Then what you will get? Then here you will see that here this chloride and this chloride will be cancelled out. OCl, Cl minus. And second is Cl minus half Cl2. Then both chloride will be cancelled. Both chloride ion will be cancelled. Then what is remaining? Remaining will be OCl minus and Cl2. Correct? This will remain. Okay. This what you have to calculate? You have to calculate this. Only this will remain. OCl and this will remain. Cl cancelled. Here just you can see that two reaction was there, two equation was there. Then first equation was this. Second equation is this. Both you add. Cl will cancel. Then OCl will remain, and left side and right side half Cl2 will remain. That you can write like this: OCl minus oblique half Cl2. Correct? Then because you are adding, then this also you add, potential you add. Then potential when you will add, then what you will get? 0.94. And this was minus 1.36, second one. Then when you will add, then plus minus minus. Plus minus minus. Then 0.94 plus inside the bracket minus 1.36 means 0.94 minus 1.36. After that you will get this minus 0.42 volt. Minus 0.42 volt. Then given option you can see first option is matching. First option is matching. Hence first option is the correct. Okay. This is the correct option. Minus 0.42 volt. This question was asked in Haryana CET. Now, second question I am telling you. Which of the following will provide maximum voltage? Maximum voltage. Given that it is a given cobalt to cobalt. Cobalt ion is converted to cobalt, one electrode. Its potential is minus 0.28 volt. It is given. Second, also it is given zinc ion to zinc. Its potential is minus 0.6 volt. And third, silver ion to silver electrode. Its potential is 0.80 volt. And next, copper electrode. Copper ion to copper. Its potential is 0.34. Means 4 electrodes potential is given. 4 electrodes potential is given. Then now you can say tell that which of the following four options are there, will provide maximum voltage. Then first option is this, cobalt solid plus 2H plus aqueous, that is given cobalt 2 plus cobalt ion aqueous plus H2 gas. This is the first option. Second option is this. Second option. The first option is the second option. Half Zn solid plus Ag plus, it is giving half Zn plus Ag solid. This is the second option. Third, H2 gas plus Cu2 plus aqueous, that is giving 2H plus aqueous plus Cu solid. This is the third electrode. And fourth, third electrode is actually, this is this thing, cell reaction. And fourth one is Zns plus copper ion aqueous, Zn solid plus copper ion aqueous. It is giving Zn plus aqueous plus copper solid. Then four options are given. Then you have to tell which of the following will provide maximum voltage. And this electrode potential, four electrode potentials are given. Correct? Then now you consider how will you solve. Now I am telling you. It is little complicated, little, not more. Calculation is more. Then first option you can see all four electrode potential you have to consider. All four. Then value already I have told you. Correct? Cobalt electrode potential is equal to minus 0.28 volt. Zn electrode potential is minus 0.76 volt. Silver electrode potential is 0.80 volt. And copper electrode is equal to 0.34 volt. Here you have to see very, very important things. Here actually this is reduction. Cobalt is converting to cobalt, reduction. Here also it is reduction. Zn ion is converting to zinc. Here also it is a reduction. Silver ion is converting to silver. Copper ion is converting to copper. Means all are reduction potential. All are reduction potential. Then if all are reduction potential, then it is very easy to calculate E. How? Then already I have discussed that E is equal to E cathode minus E anode. Means right hand side electrode minus EL, left hand electrode. Then this formula you have to use. E is equal to E cathode minus E anode. This you always you can apply. If reduction potential you are knowing, standard reduction potential, then just this formula only you can use. Then in all four cell reaction, in option 4 cell reactions are given. For each cell you calculate electrode potential, each cell. For each four, only then you can tell which cell will provide maximum voltage. Don't think that it is a big question, is big, but you can solve it easily. I am telling you now. Here I told you that cathode minus anode, that you have to do in all four cases. Then if you will do like that, you have to find out which one is cathode, which one is anode. Then for that, you have to, in your mind you can think by seeing the reaction. Here you can see which is going, first option, hydrogen is going to, hydrogen ion is converting to hydrogen, means reduction process you find out first. Reduction process, only one. Second, automatically left will be anode. Then hydrogen is ion is converting to hydrogen, means hydrogen electrode. Hydrogen electrode is reduction. Correct? When cathode. Hydrogen electrode will be cathode. Then hydrogen electrode minus cobalt electrode. Then hydrogen electrode potential is not given. Correct? Hydrogen electrode potential you see in all four. Hydrogen is not given. Then how will you calculate hydrogen electrode potential? You don't know. But this is a standard. You should know. Hydrogen gas is arbitrary given 0 voltage. 0.00 arbitrary without any reason and rhyme. Its value is given as 0. This is a standard. Always you should know. Okay. Then now for here you will write E cathode minus E anode. Then cathode is hydrogen. Then its value is 0. 0 minus, and in bracket now this cobalt reduction potential is minus 0.28. Then minus plus. Then 0 plus 0.28 means finally you will get 0.28 volt for the first cell. Now for second cell now second cell is this Zn plus Ag plus Zn solid, half Zn solid plus Ag plus it is converting to Zn ion plus Ag. Here just to find out which one is cathode. First to find out cathode. Then here you can see Ag plus is converting to Ag. This is the cathode. Then first you have to write cathode electrode potential. Then now for this, for cathode it is given. For cathode it is given 0.80. Then 0.80 minus anode. Anode is what? Then anode is zinc. The zinc value is given minus 0.76. Then cathode that is the silver. For silver is a 0.80 minus in bracket minus 0.76 minus plus means just to add both 0.80 plus 0.76, then you will get 1.56. Correct? For third cell you calculate. Third cell is here. H2 gas. Here you can see copper ion is converting to copper metal. This is the cathode. Then cathode, what is value given for copper? When the copper it is a 0.34. The 0.34 minus in bracket hydrogen gas. Hydrogen gas is there. For that it is a 0. Then same will be the E cell. Correct? Means copper is given here 0.34 minus 0. Then you will get only this 0.34. Then third here this things third you got 0.34 for the third cell. Similarly for the fourth cell is Zn plus copper. Here again copper is converting to copper solvent. This is the reduction. Then again copper is equal to 0.34 minus what is the other? The other is zinc. Correct? Then zinc is given minus 0.76. Then again minus plus. Then just to both you add. Then 0.34 plus zinc minus become plus 0.76. You will get 1.10. Then see, you have calculated for all four cells. You calculated E cell. Then now see which one is more, which value is more. Then here see B. B is more. 1.56 is more. Hence correct option. Correct option now you can this will correct answer will be what? B, cell B. This is the correct answer will be B. Correct? I think now it is clear. Actually, this is the long. In short, in very fast way, you have solved 4 numericals. 4 numericals. Correct? Because 4 option was given, that was the reaction cell. Then for the 4 cell, you have calculated E cell and then you have compared. That's why these 4 you got E cell value. Then you have seen that this is more. Hence correct. The second option, second cell will provide maximum voltage. Now, third question I am telling you. The EMF, listen carefully, question, then only you can apply your mind. The EMF of the cell involving the reaction 2Ag plus aqueous plus H2 gas, it is giving 2Ag solid plus 2H aqueous is 0.80 volt. EMF of this cell, EMF of this cell reaction is given. Its EMF is 0.80 volt. Standard oxidation potential of silver electrode. Standard, you have to calculate standard oxidation potential of silver electrode. First option, what will be the oxidation potential of silver electrode? Then here 4 option is given. First option is 0.80. Second option is 0.80 volt. Third option is 0.40 volt. Fourth option is 0.20 volt. How you will tell without solving? Without solving you can't tell, simply you can't guess. Then here you have to solve it. Then how will you solve? Then now just you think for this reaction only. You have to tell silver electrode oxidation potential, not the reduction. But to tell the oxidation potential, you have to calculate the reduction potential. Correct? Without calculating reduction potential, you can't tell the oxidation potential. Then now see here how we will calculate. Again, I told you, E cell you can calculate in 2 ways. E cell is equal to E oxidation potential plus E reduction potential. This is the one way to calculate E cell. Second, many times I told you that E cell is equal to E cathode minus E anode. In any way you can calculate. Result will be the same. Then here, what you feel in that way you can calculate. Okay, no problem. Then here E cell is equal to E reduction. E reduction plus E oxidation. Correct? Then here in question, E cell is given. E cell is given 0.80 volt. Okay, this is given. 0.80 volt is given. And here, this thing, sir. Here you can see again hydrogen gas electrode you are using. Hydrogen gas electrode. Then for hydrogen gas electrode, what is the reduction potential? It will be not given. You should keep in mind. Reduction potential value will be not given. You have to understand. You have to keep in mind. This is the fixed value. All should know. Then for this it will be 0. Then this E reduction. E reduction for silver it is, for the cell it is given 0.80. And Ag you want to calculate. Ag you want to calculate, and for hydrogen it is 0, already 0. Then what is the this 0.080, that will be the reduction potential because it is 0. Correct? Reduction potential plus 0. 0 you remove, the only reduction potential of silver, and that is equal to 0.80. 0.80, that is the reduction potential. Reduction potential is plus 0.80. Then what will be the oxidation potential? Just reverse the sign, that's enough. Oxidation potential, you can convert it easily in reduction potential to oxidation potential only by changing the sign. If negative is there, then it will be positive. If positive is there, it will be negative. Then now it was positive, then now it became negative. Oxidation potential of silver is oxidation potential, that is the minus 0.80 volt. Now question number 4 I am discussing now. Listen carefully question. The EMF of the following cells, again question is long. Okay, the EM of the following cells are, okay, cells they have given. How many cells are there? You can see one cell. After that, this is the second cell, and this thing, sir. The EM of the following cells are, two cells are given. This is the first cell, copper electrode plus silver electrode. Its value is 0.46, and second electrode is this, zinc and copper electrode. Its potential is given. Two cells are given. First this cell, copper and silver cell, and second zinc and copper cell. Two cells are there, and for both, you can say this voltage is given. Each cell is given 0.46, and so for second 1.10 volt. Then now you have to calculate EMF of the cell they have given. New cell they have given. Okay, new cell, Zn and silver electrode. These two cells are different. This is the different. Here you should remember, two cells what they have given, that is different. This is also different. Then for this zinc and silver electrode you have to calculate. Copper and silver is given, zinc and copper is given. But you have to calculate EM of the cell, that is the zinc and silver. Then what is the EM of this cell? It is given, 4 option is given. First is 1.56, second is 0.64 volt, third is minus 1.56 volt, fourth 2.02 volt. Okay. Then now how will you tell? This is again different type of question. Okay, not a straightforward, not easy. You have to just think. Okay, you have to just think how will you get this cell. But you will get that this cell, third cell, you will get only from the first two cell. To get the third cell, you have to think first and second cell. Correct? By the use of first and second cell, you will get the third cell. Then now just you think. I think easily, if you will, little things you have to think. It's not very complicated, but you have to think, apply your mind. Then here you can see, you want, here actually it is given, silver electrode, here that silver electrode potential minus copper electrode potential. That you consider. How you got this thing? It is not given. It is not given. Only cell is given. Only cell is given. Two cells. And third cell you have to calculate. Then how will you get this silver electrode? Electrode potential of silver minus electrode potential of copper. That is actually in indirect way. In indirect way, they have given value 0.46 volt. Then you know that always E cell will be E cathode minus E anode. Then directly E cell value is given. Then you can write E cell is equal to E cathode minus E anode. Only thing is that now you have to think which one is cathode and which one is anode. Simple things. Then for this cell, for first cell, this is the cathode. This is the cathode, silver cathode. Correct? Then here, that's why we tell cathode minus anode. This is the anode, copper will be obviously anode. Then that, this minus this is equal to 0.46. You can tell equation 1. Similarly, second you can write same way. Copper is cathode. Copper is cathode. Then first you write copper. Copper first you write, and this thing, sir. Cu, where is this? Fourth one. Second one. Then copper is cathode. Zinc is anode. Then you can write that here copper. You should write copper. Okay. Then cathode minus anode. Copper is cathode. Zinc is anode. That's value is given plus 1.10 volt. Then now it is a second equation. First equation, second equation. But now just simply you think, how will you get? You want what actually you want? Then you want this. You want this. Okay. You want this. Ag, electrode potential of Ag means silver electrode, minus you want zinc electrode. You want this according to the question. Correct? You want this here the EM of the cell. This is the given cell. Then that you can write in this way also. Silver, because it's cathode, silver cathode minus zinc electrode. For that, what will be the value? E cell. For this cell, what is the E cell? You have to calculate. Then just you see the both equation 1 and equation 2. That if you will add equation 1 and 2, then this copper electrode and copper electrode will be cancelled. This will be cancelled and this will be cancelled. Okay, both will be cancelled. Then what you will get? You will get this minus this, silver minus this. Correct? Then just to add both this and this, because we are adding, then you will get 1.56. E cell is equal to 1.56. Then now answer you can see. Option you can see. Then option now 1.56. Here option A is only 1.56. Correct option. Simply you can't mark it. You have to solve the numericals. Only then in a confident way you can tell that this your answer is correct. Now one more question I want to discuss. Question number 5. Now I am reading. The half cell reaction used in hearing aids are this Zn is converting to Zn ion plus 2 electron, and its potential is given 0.76 volt, and other electrode is silver Ag2O plus H2O plus 2E. It is giving 2Ag plus 2OH minus. Okay, this is the second electrode, and its electrode potential is 0.34 volt. You have to calculate E standard of the cell will be. What will be the, you can say E of the cell. 2 electrodes they have given. Here new things also you are knowing that these reactions takes place in hearing aids. Hearing aids. Okay, this is a separate question. Hearing aids now it is used by elderly people, those who are not listening properly. Then in that cell, there they are using cell. Okay, then half cell, 2 half cells they have given. In a cell, two halves are there, you know that half shell plus half shell, it will give full cell reaction. Then half cell reactions used in hearing aids are first actually reaction is this half cell reaction, means anode, cathode reaction. Then this is given, zinc is converting to zinc ion and potential is 0.76. And in second electrode silver oxide is used. Silver oxide Ag2O in the presence of water means H2O. Reduction takes place, plus 2E means reduction. It is converting to metal 2Ag plus 2OH minus. Here main thing is that here you can see oxidation is going on. Half cell reaction, first half oxidation reaction, and second reduction reaction is going on. Addition of electron Ag2O is converting to metal 2Ag and potential is 0.34 volt. Correct? Two electrodes are there and they are given potential. Then you have to tell the standard E of the cell, because two electrodes are there. If you will join, it will form electrode. Then simply you just E cell you calculate, which is made from these two electrodes. Then same way, E cathode minus E anode, that is equal to E cell. Then which one is cathode, which one is anode? Now it is very clear that silver oxide is cathode. Correct? Then its value is 0.34 and zinc is anode. Here you have to understand that, see, in the question they have not written that reaction given voltage is reduction potential or oxidation potential. This is not mentioned. You have to understand that here this potential is given, but what type of potential is there? It is not written whether it is oxidation or reduction. But you have to understand that reaction is zinc. Zn is converted to Zn ion. It means it is the oxidation process. And its potential is oxidation potential. Here is very, very important things. 0.76 is oxidation potential. But in formula, to calculate E cell, E require both should be reduction potential. Then second one is already no problem. This potential 0.34 Ag2O plus H2O plus 2 electron, you will get 2Ag plus 2H minus. This is already reduction potential. Then you have written here 0.34 minus reduction potential. Then this was plus 1.56. Now just reverse it because that is the oxidation potential. This 0.76 here 0.76. This oxidation potential, make it minus 0.76. And here you write in bracket minus 0.76. Minus plus, add both, you will get 1.10 volt. Then given option you can see, first option was 0.42 volt. Second was 1.1, third was 0.84 and fourth was 2.24. Then see here, second one. 1.1 volt means 1.10 volt. That's correct. Answer is option B. Then today I have discussed 5 numericals, all are different type, and in examination either in medical or IITJEE, particularly this type of, at least they will ask in one can ask in one or two can be asked in advanced level, and rest 3 can be asked fit for medical and mains. Okay, then different type of questions I have discussed today. Now I am stopping only here. Next class again I will continue other numericals, other important numericals, that may be hard numericals. Thank you.